Hello everyone. Today we are going to discuss about symmetry and group theory. Myself, Dr. Mallikarjuna Swamisi, Assistant Professor, Postgraduate Department of Chemistry, JSS College of Arts, Commerce and Science, Mooty Road, Mysuru. See, as we know, nature loves symmetry. Okay, if you consider any molecule in our chemistry, all molecules have to possess some symmetry. Okay, so if you see, definition for symmetry, if a molecule is having two or more indistinguishable configurations, then the molecule is said to possess asymmetry. You can see the picture butterfly. It is having symmetrical feathers. Okay, and if you can consider Taj Mahal, if you look at the picture, you can easily observe what is the symmetry. Okay, and you can easily see the two towers which are equidistant from the center. Okay, likewise, if you consider any molecule, all molecules said to possess a symmetry, then only that can easily show a different applications, right? In this symmetry, we have two terminologies, very important terminologies. What are those names? The first one is symmetry element and second one is symmetry operation. Okay, these two are interlinked. Okay, you just consider symmetry elements. Okay, we have 5 different types of symmetry elements. What are those? The first one is identity. Okay, it is represented by a symbol E, and the second one is proper rotational axis. We can also call that one as rotational axis of symmetry, and that is indicated by Cn. Okay, C represents cyclic rotation and N represents number of times you are going to rotate the molecule to get original structure. And the third one is plane of symmetry. We can also call that one as mirror planes. In that mirror planes, we have 3 different types. The first one designated by sigma h, that indicates horizontal plane. Okay, and second one is vertical plane. The designation is sigma v, and the last one is sigma d. D indicates diagonal planes. Okay, and the next fourth one is inversion center or center of symmetry. That center of symmetry represented by a letter small I. Okay, and the last one is improper rotational axis of symmetry. That is represented by Sn. See, there is a matching in improper rotational axis and proper rotational axis. Proper means if you consider any molecule, say for example, you consider water molecule, right? Here, center we have oxygen, and this red ball and this red ball indicates hydrogen. Okay, hydrogen. So here what happens, if you start rotating this molecule by 180 degree, see, we are maintaining only one type of rotation. See, you can rotate this molecule either clockwise or anti-clockwise. Okay, so this is what proper rotational axis. And if you consider last one, which is improper rotational axis, here what happens? Improper, name itself indicating that this is somewhat improper. You cannot easily rotate this molecule. If you rotate, definitely you will get original structure. But some molecules, if you rotate molecules, you will not get original configuration. Instead, you will get somewhat different structure, but according to symmetry, that molecule said to possess 2 or more indistinguishable configurations or original structures. So, in improper rotational axis, first you rotate the molecule and then you reflect. That's why the name indicates improper rotational axis of symmetry. Okay, that is what main difference between proper rotation. Name itself indicating that properly you need to rotate, whether cyclic or anti-cyclic. You should continue same in order to get different configurations. Okay, original structure. And then let us move on to next one, that is, okay, consider first one, that is proper rotational axis. We can call this one as rotational axis of symmetry. What is the definition? It says that if a rotation of a molecule by 360 divided by n results an indistinguishable configuration, okay, then that molecules have n-fold rotational axis. Let us consider simple example, same water, right? See, we are operating this. Okay, operation means you need to rotate this molecule only 180 degree. Okay, only 180 degree. That is what n represents 2. That indicates 180-degree rotation. Then only you will get indistinguishable configuration. Say for example, you consider this is original structure of water molecule. If you rotate this by 60 degree like this, you will not get original configuration. That's why in order to get this original configuration, you need to rotate this molecule by only 180 degree. Only 180 degree. See, first you assume here, you just label this one as H1 for our convenience, and you consider this one as H2. Okay, actually we cannot differentiate which one is H1 and which one is H2. In order to understand this proper rotational axis, we are just representing this right side as H1 and left side as H2. And then what you are going to do now, you need to rotate this. Just you pass one imaginary line through this oxygen. Okay, and then I will hold like this, and then we are going to rotate this molecule either clockwise or anti-clockwise. You just give rotation. The two rotation should be 180. Why? Means we should get original structure. That's why we are fixing rotation to 180 degree. Okay, so then you start rotating this molecule 180. So see, you cannot differentiate previous structure to this structure. Okay, it looks same. That is what actually definition of symmetry. Again, if you rotate this molecule by another term, which is 180, you will get original structure. Okay, so according to definition, if a molecule is having one or two or more indistinguishable configurations, then those molecules said to possess symmetry. Okay, this is very simple. N 360 divided by n, nothing but n is equal to 180. So 360 divided by 2, you will get 180. Means if you rotate this molecule 2 times, you will get original configuration. But if you rotate this at 180 degree one time, you cannot easily differentiate what is the original structure of this molecule. Okay, this is one example. It belongs to C2 rotation. Okay, now you consider another molecule which is ammonia. Okay, ammonia. See, as you know, center we have nitrogen, and here we have hydrogen, here we have hydrogen, and here we have third hydrogen. For our convenience, we are designated this one as H1, H2, H3. This H towards U, and this is what another one, and this is what another one. See, to get indistinguishable configuration, we need to apply some operation. What is that operation? Rotation. Okay, we are doing rotation. See, operation means anything. We should some restrict rotation. Means in order to get original structure, you need to rotate this molecule by 120 degree. Then only you cannot able to differentiate original structure. Okay, let us try. See, your imaginary line pass through the center. Center nothing but nitrogen. Okay, means the molecule's mass concentrated on nitrogen. Okay, so you pass one imaginary line and then you make a rotation. Rotation should be 120 degree only. Now this hydrogen towards you. I will start rotating this molecule. See, now I am rotating. See, another hydrogen heading towards you. Okay, see, this is what first rotation, single rotation. And again, I will start rotating this molecule 120 degree. See, another hydrogen come to this position. Again, if you rotate one more time, that is n is equal to 3. So if you rotate this molecule, you got original structure. Okay, so this is what C3 rotation means. This molecule is having C3 rotation. Why? Means if you rotate this molecule 3 times, you will get original structure. That's why 360 divided by n is equal to what? 3. So if you rotate this molecule 120 degree 3 times, you will get original configuration or original structure. This is an example for C3 rotation. Along with this rotation, we have other elements also, like plane of symmetry. Okay, you cannot find improper rotational axis, and it does not contain any inversion center, but you can place a plane. Okay, let us discuss that one. Second, plane of symmetry. Okay, plane of symmetry. See, here we are considering BF3 molecule. Okay, BF3 molecule. What is the geometry of this one? Planar, trigonal planar. See, you can place molecule like this. Okay, molecule like this. See, it is having a plane, right? So otherwise you consider like this. See, if I remove this molecule, means element BF3, I have taken example BF3. See here, you neglect this, you consider as water. Okay, water. See here we have oxygen, here we have hydrogen, here we have hydrogen, another hydrogen. See, according to a plane of symmetry, see, plane of symmetry means we are placing a plane here. Okay, just you place a mirror here. Okay, mirror. You remove this. If you remove this, if you place a mirror here, what happens? This hydrogen reflects. Okay, reflects means if you remove this hydrogen also, you cannot easily differentiate the structure of the molecule. Structure of the molecule. This is what a plane of symmetry. See, plane of symmetry nothing but if you cut a molecule into two equal halves, you cannot easily differentiate original structure. Okay, two or more indistinguishable configuration. See, in this molecule, we can easily identify two planes. One is this one. You can place a plane like this. Another one, you can cut individual elements. See, here we have hydrogen. Here we have oxygen. Here we have hydrogen. If you want to cut this, you cut molecule and you place a mirror. So it can easily identify original structure. Okay, same like original. You cut this molecule and place a plane or a mirror, you can not easily differentiate previous structure and this structure. This is what plane of symmetry. As I said earlier, in this plane of symmetry, we have three different types. The first one is vertical plane. Vertical plane is nothing but a plane which contains principal axis. Principal axis means, as we discussed, here we are having center of axis, central axis. By that axis, you can easily rotate this molecule. Along with rotational axis, if you are having a plane, that is nothing but vertical plane. A plane which contains principal axis, nothing but vertical plane. So here we have vertical plane. See, like this. One vertical plane we have, and we have another vertical plane like this. Right? Here we have axis of rotation. Along with this axis of rotation, we have one plane and another plane. So if you consider this water molecule, we have two times rotation to get indistinguishable configuration, and we have one plane and another plane, which indicates two planes. We have sigma V1, sigma V2. Okay, and you consider another example, which is same ammonia. Okay, as I said, it has three rotation, 120 degree. If you rotate 3 times, you will get indistinguishable configuration. Along with that, we have three sigma planes. What are those? See, what is the definition for sigma V? Vertical plane, nothing but a plane which contains principal axis. See, we have principal axis. Along with this principal axis, you can easily cut this molecule into two equal halves, or here if you place a mirror, this hydrogen reflects and it confirms that it is having a symmetry. See, one sigma V, another sigma V, and the third sigma V. So in general, if you consider this ammonia, it has C3 rotational axis, and 3 sigma V's. What are those 3 sigma V's? One sigma V, another sigma V, and another sigma V. Totally 3 sigma V's present in this ammonia molecule. This is regarding plane of symmetry. See, the two vertical plane. And if you consider another example, let us take BF3 molecule, trigonal planar molecule. This is trigonal planar molecule. See, this molecule is having horizontal plane. Horizontal plane, nothing but what? See, if you consider this molecule, here we have rotational axis, right? Horizontal plane is nothing but a plane which is perpendicular to principal axis, right? Horizontal plane, nothing but what? Here we have principal axis. To this, perpendicularly we have a plane which is horizontal plane, right? So you consider any structure or a molecule which is having planar, then those molecules must contain horizontal plane. Okay, horizontal plane. And what about vertical plane? Whether this molecule is having vertical plane or not, can you differentiate? Yes, this molecule is having vertical plane also. See, let us consider. Here we have principal axis. You can cut molecule like this. See, we are cutting this F molecule and B molecule. So, you cut this molecule and you place a mirror. This will reflect. There is no indistinguishable structure. Okay, so one sigma B, another sigma B, and another sigma B. Okay, this is what it contains. 3 numbers of sigma V's and 1 horizontal plane. Okay, what about dihedral plane? See, according to definition of dihedral plane, see, dihedral plane nothing but a plane which bisects 2 consecutive C2 axes. 2 consecutive C2 axes. What are those 2 consecutive C2 axes? See here. See, in order to explain dihedral plane, I am going to take PTCl4, which is, see, this is what PTCl4. Center we have platinum, and here we have Cl, Cl, and Cl, and Cl. What is the shape of this molecule? The shape of this molecule is square planar. Square planar. Okay. According to definition, sigma D nothing but a plane which bisects consecutive C2 axis. Okay, C2 axis. See, for example, what is the meaning of C2 axis? See, for our convenience, we are placing molecule like this, right? See, you pass one imaginary line like this, okay, through this platinum. You pass imaginary line and you rotate this molecule by 180 degree. You cannot easily differentiate. Okay, again, if you rotate this molecule, you will get what? Original structure. Okay, see, if you rotate this molecule one time, there is no equivalence between previous one and this one. See, these two shift to other place. Again, if you rotate second time, it comes to original structure. Okay, so this contains what? C2 rotational axis. And if you pass a line, another one, C2, like this, okay, you can rotate this molecule one time and 2 times to get indistinguishable structure. So, according to definition, sigma D, dihedral plane nothing but a plane which bisects 2 consecutive C2 axes. See, here we have C2 axis 1 and here we have second C2 axis. Between these 2 C2 axes, we have one plane, right? See, if you cut this molecule like this and if you place a mirror, you can easily come to know indistinguishable structure, right? So, according to sigma D, if the plane contains or bisects 2 C2s, here we have one C2 and here we have second C2. In between these 2 consecutive C2s, if you pass a plane, that plane is nothing but what? Sigma D. Okay, sigma D. This explains dihedral plane, right? See, by considering this, see, somewhat highly symmetric. If you consider water molecule or ammonia molecule, among those 2, this one is having highly symmetric. See, you can observe how symmetrically all 4 carbons attached to platinum molecule, right? So, by using this simple molecule, you can easily differentiate 3 sigma V's. What are those? First one, as I said, vertical plane. See, vertical plane nothing but a plane which contains principal axis. See, here we have principal axis, right? Through this principal axis or along with this principal axis, you can cut the molecule. Okay, you can cut the molecule. Like this, you can cut. Like this, you can cut, or along with Cl, Tt and Cl, you can cut the molecule, or you can place a mirror. You will reflect. You can get reflection. So, indistinguishable structure. So, this molecule is having what? Vertical plane, and another plane is horizontal. Horizontal nothing but here we have principal axis. The axis or a plane which is perpendicular to principal axis. Here we have principal axis. To this perpendicularly we have a plane which is horizontal plane. Okay, and the third one is sigma D. D indicates dihedral. Dihedral plane nothing but, see, here we have one C2 and here we have another C2. One C2. See, 2 times. If you rotate, you will get original structure. If you pass imaginary line like this, you rotate 2 times, you will get original structure. Between these 2 C2s, we have one plane which pass through the Cl, Pt and Cl. This plane is nothing but dihedral plane. Okay, dihedral plane. I think you got information about the plane of symmetry in that three types. One is sigma v, another one is sigma h, another one is sigma t. Okay, this indicates plane of symmetry. Okay, thank you.